courtesy basics. And you guys are lucky. If you were in class, you couldn't read this slide. I can't read the slide. And as we go through, what you'll find out is, because I'm used to standing in front of a group with a slide behind me, we just kept the procedure the same, but you're actually on your device are going to be watching a slideshow. And so if you just get an idea of where my hand is or where I'm pointing, then you can look at your device and see what we're looking at. So anyhow, this is all new to us. We've done a couple classes, and we've still got people joining us the way it sounds. But one of the first things about remote learning is common courtesy. It's basics that everybody has to learn. Teams, there's many different formats for remote learning. We're using Teams here, and maybe that's not something, or it's new to a lot of us. So there's some we're going to point out how to do certain things. The first thing we're going to talk about is when you join a meeting, or as soon as you get on, you want to mute your mic. And then I have to,
because we can right now, we can hear some guys that are signing in, and we can hear you moving things around on your desk or playing with your phone. So if you guys are already on the Teams, if you'll mute your phone, in the center of the screen, if you hover over it, you will then get your camera, your mic, all that, put an X through it.
And we're going to show that very, very quickly. The other thing is, just like in any other class, grab a notebook, take some notes, because we don't have a booklet to give out for you to fill in, but take some notes as we go through this. And then the other thing would be ask questions. This is a two-way street for us, and we're going to show you and tell you how to do that. So on this slide here, that is not either one of us, but if you can see, it should be on your screen now, the arrow is pointing at a video camera. Make sure there's a line through it, a circle with a line through it. That just shuts off your camera. We don't need to see your face, what you're wearing, and we don't need to use up precious bandwidth. So we don't need the videos on at all. So just make sure there's a circle with a line through that. The next one over is the microphone. That's one of the most important ones. Make sure there's a circle with a slash line through it also, and that will show that you're unmuted, like somebody's not right now. So now, as we go through here, if you have a question, you may at any time, you try to pick the appropriate time, but you can unmute yourself, ask a question, and then immediately mute yourself back up again. However, probably the best way to ask a question is what the arrow is pointing at now, like a notepad. That's going to be our chat button. So you can hit the chat button, and then you'll get a little screen off to your right-hand side where you can type in questions. We have another DSG with us today, monitoring and kind of running the show. That's Doug Zerby. We appreciate what he's doing here today, too. And he'll review your question, and he might send a reply, or he may put his hand up, and we know there's a question out there, and the question will identify the way, because we don't like questions, holding out there, because we hate to change the subject and then go, have to go back. We're glad to do it, but we'll try to keep it in, just like it's class, just like you're here in class. That's what this is all about. So, if you have any questions about that, shoot us a chat, or unmute your mic and bring it on. Okay. We always like to start with a safety minute. This is the Ferguson way. We're all concerned about safety. Somebody's not muted that really needs to be. We're going to try. We can't find it on our end. So we'll try to keep on going. Let's just talk about safety right away. Windows for today. Be careful, okay? Electricity. We're all dealing with electricity, and electricity can bite you. it has the capability to kill you. We don't want to see anybody getting hurt. Okay, so go ahead.
And I was going to just say, and assuming that since we're talking today about the Mitsubishi service, which means that the guys are going to have to get into that piece of equipment,
right?
We're going to have to remember that there's going to be a bleed off time. Okay, so the safest way to do that is when we do pull our disconnects, when we do that, we're going to watch for our lights to bleed down.
Okay.
And when they bleed down, then we're usually pretty safe to know that when we lose the lighting, the LED lights that are on the board, then it's safe to go in and start pulling plugs off of it or checking things, unless we're doing a live voltage check, which we have to be careful of. But please remember that you are working also with DC voltage when it comes to the ductless line. I know we have pictures of what we're normally used to seeing as far as AC voltage, but we are dealing with DC on these units.
Right. We don't want that happening to you. So yeah, and along with that, we use very high DC voltage. And DC will bite you harder than AC will, and we've got over 300 volts DC in some places off these boards. So we must be very, very careful. Always measure, okay? So along with letting the lights die, we can test at various places to make sure the power is off. You pull the disconnect. Just don't assume that pulling the disconnect is killing the power or shutting off a disconnect. I've been out there where I've shut disconnects off and somebody had wired around on one leg because it was a bad contact. They probably meant to get back, but it was still live, okay? So, and then also along with that, we talked a little bit about grounding. And the reason I left this slide in here is because with Mitsubishi, grounding is super important. Any of these new products that are out there that are using electronics it's super critical to have a good ground. So just don't assume because that green wire that's on the cabinet from the equipment is wrapped around a screw that's grounded. It needs to be grounded all the way back to the panel and beyond. I've been in situations where the ground went all the way to the panel, but we found out the ground wire, not the neutral, but the ground wire had lost its connection to the rod out in the outside, and we didn't have a ground, and that affected the way that the furnace was working in that case.
And again, bringing it back to the Mitsubishi world,
right?
We've got multiple units. So we have a unit outside that needs to be grounded. We may have an indoor unit head with circuit boards that needs to be grounded. We may have a branch box inside that needs to be grounded. So when you get these multiple layers of electronic boards, a grounding issue can really kind of hide itself and cause us a lot of communication errors, operational errors, and it comes down to just a poor ground.
Right.
And so, yes, grounding is very important.
Very critical. So let's be safe. Let's test for voltage before we work on equipment if we're anticipating pulling it apart, and watch our grounds. So here's the beginning of our official course. So Mitsubishi maintenance, it's maintenance and service we're going to talk today about. We interject maintenance and service together as we go through. We tried to be as straightforward as we could. Maintenance and service just kind of like all goes together. You're maybe out there on maintenance and you find, I get that call all the time. I was here for preventive maintenance or PM. I may, abbreviate it as, I know others use other abbreviations, and all of a sudden we see something that's not right, or, and I'll get a call on it. So it goes together. We talk about starting before the front door. And that has to do with, really, you should have a company procedure. And we think about, and many of your companies do, but it could be things like, where do you park your truck when you pull up to the house? I know every time I pull up to a garage, and there's two-car garage, it never failed. I was always parked in the wrong spot, that was the door they needed to open and leave. Maybe some companies may have a policy where you don't go in the driveway. You may, maybe best to stay parked in the on the street. It saves, ripping down the basketball, court with your ladder rack. I know that.
Well, drive-throughs always got me.
Oh, drive.
Arby's in Quakertown.
Uh-oh.
Yeah.
Yeah, Between the two of us, we are easily able to go off on tangents, so we'll have to hold each other in check. But yeah, when you've been doing this stuff as long as we have in the service, being out in the service field, we've got stories. Anyhow,
I do want to say this though, Jim.
Sure.
For the people that are out there watching today, this is a Mitsubishi maintenance class. This particular class is actually put together by our group.
Right.
Okay, this class you're not going to find on Mitsubishi's website, such as Link Drive. You're not going to find it in their learning, because basically it is not a class that they put together for us. They only offer the 4-hour class and the 2-day class. This is something that Jim and I and Doug and others have put together to try to help you guys out with what is the basic maintenance, what is the service. Some slides will be things that you may have seen from Mitsubishi,
right?
But a lot of this is just basically, this is where the rubber meets the road. This is how we do it. This is what we're recommending for this class. So I just wanted to get that through, that this is not NATE certified. It doesn't come with any certification on it. It's just a class that we felt was extremely important to have.
We recognized a need for service. One of the, not complaints, but one of the comments that I would get is, we never have any problems with the Mitsubishi units. And that's true. As long as you put them in correctly, you, in all likelihood, won't have a service issue, hopefully for many years. But because of that, you never get any experience for service. So what we felt the need for was a way to present some minor service issues. And what we did is we broke this class down into 2 sections and maybe 3 if we run long. We could add a session and you can come back and look at it. We're taping this and it'll be available somewhere. Use your TM for information as far as how to find that. But the first session that we're going to go through is a PowerPoint of slides. We wanted to hit some highlights for the maintenance and service. The second session, what we've done is we've put together various scenarios of actual service calls that came into us or Mitsubishi, and we're actually going to work through. So what we'll do is we'll say, here's the no cooling, here's my symptoms, how do we solve this issue? And we're going to walk through it step by step, and we find that that's very helpful for most technicians. Show you where we can find the answers and kind of lead you through the procedures that we go through as we come up with helping people.
Correct.
So, okay. Another thing is, do you wear booties? Things like that. Respect for the home, your appearance. That always has an effect on the customer. And how you greet your customer. You just walk in and,
So realistically, what happens is what we're finding out, and particularly in today's society, okay, when you knock on that door, your maintenance call really begins right as you pull it, basically pull in. Because when they open the door, I've noticed just recently going out on field visits, they gaze down to see if you've got booties on. Yeah. There's certain expectations that they are looking for. Today, it may be a mask. It may be gloves, it may be booties, and they're looking at that saying, you're coming into my home, how are you protecting me, how are you protecting yourself?
Right.
And so, and it is changing day by day, especially in the HVAC industry, because we are in the people's homes all over the house, check things out.
Right, they don't know you, they don't know where you're coming from, where you were the last, the service call before that, what you may have picked up and what they don't want in their home. So these are strange times that we're dealing with right now, and it's a challenge for everyone. Okay, let's keep moving on. One of the first things we want to do when we walk into the home is, we call it interview and consult the customer. And this is just confirm why you're there exactly, especially on service calls. I've been out there on service calls, and I go to a home and I'm walking in on a no heat call. And, that call may have come in to, back in my day, we had answering services or what, I guess we still do. But that may have come in over the night. Somebody in the office got the message. They sent it to the dispatcher, who's now sending it to you. And it's like whisper down the lane. And, you may be expecting a no heat call and you're there, end up, it's a noise somewhere from a unit. So just, what we're saying is just talk to the customer and confirm exactly what their issue is, validate the concerns. Okay. Some of the things that you can ask them, I mean, not from every job, but, one of the things that's always good to know is, when was equipment installed? I mean, if it was installed last week and they've got an issue, well, maybe you're dealing with an installation concern. What's the primary concern? Why are you there? It just make it as simple as saying, ma'am, I have a preventive maintenance work order here. Do you have any concerns?
Right, and then that's when she's going to say, well, didn't I tell you that this thing keeps like vibrating on the wall?
Right.
It keeps us up at night, or those type of things. Those things always come out.
Yeah, we knew you were coming, so we just, we didn't call in about the noise on the wall.
Correct.
So, but that would be something, obviously, we'll get into looking at the whole system. Filter out the information, and kind of interestingly, some people keep track of every service call that that's happened on that piece of equipment since the day it was installed. And sometimes they want to go through those 14 pages. I've been there, and we have to kind of cut to the chase. So sift through the past information. What's nice now, a lot of companies have some sort of a software program where you're able to look at the past service calls, and that would have been a real benefit to me, back in the early days. Of course, we were still writing in pencil on tablets back then.
Well, the whole thing too about this is too, I oftentimes will ask a customer when I'm working on something, particularly, okay, when you're dealing with the ductless systems, Mitsubishi, like for instance, Jim, charge is so critical.
Oh my word.
And so what happened is like, oh, okay, so you're telling me that there was some performance issues. By chance, has anybody else been here? Oh, well, 3 weeks ago, a month ago, we couldn't find anybody. We had the family down and they were here for, a visit, and we needed somebody quick, and ABC company was able to come right in. And yeah, I think he said he threw a pound of something in it.
Yeah.
Okay, now all of a sudden I'm there like, okay, that may change the whole direction that I go. Because now I may be looking for a refrigerant if somebody had to put a pound in, or that past tech didn't understand what he was dealing with and understanding inverters and variable frequency of the refrigerant flow. Right. So all of that to be said is oftentimes when we're going out for service, it's just really good to have a good overview of the system and understand what's been done recently to it, if anything has been, and why you're out there.
Right. Okay, so here we go. So we want to be successful. What does success really look like? I love this slide. I think, John, you found it somewhere probably. But what does success really look like? And I just love that obviously this delivery was not successful, but yet on the side of this truck, right there, the road to success. There are no shortcuts. So don't look at, take your time. And we're going to go through things, logically. What is a successful service call? Well, identifying the issue, addressing the issue, correcting it, and leaving a happy customer, I would say. Would it be fairly accurate?
I would say that would be, yeah. And one of the other things, Jim, that I find that a successful service call also is, and you and I know, and the other guys that are here to help our dealers, is we'll often conclude with, okay, so we were able to figure this out. We were able to use Link Drive. We were able to do this. Did you learn anything today?
That's true.
And so we have to understand we're constantly learning and we're constantly evolving in our knowledge because the product is constantly changing. And so I always thought a successful thing was like, when I walked off that job, the next time I'll know exactly where to go, or that thing's not going to bite me again.
Right.
You know what I mean? Like I learned something to it. Plus, the consumer is now satisfied. And then the other big thing is like we really want to make sure that we took all the steps to cover anything that might be going on because we really don't want a callback.
Oh,
no, we don't. We don't want to hear, "Hey, you were at Mrs. Smith's last week and she called again. Something's up. It's still not right. It's still like that." To me, was like, "Oh, you got to be kidding."
Right.
And that's what we don't want. So a successful call is really that I don't go back.
Right. And my favorite is get paid at the end. That's how I always felt as a business owner. So, okay.
And that being said, Jim, and you had mentioned it earlier, and this is just a tip on the service side, guys. One of the things that I do find in collecting money and paying jobs and stuff like that today is this. If you go in and you validate the concerns of the consumer, right? If the consumer gives you pinpoints of concerns, like I have no cooling, or this is making a noise, or this is rattling, or whatever their concerns are, this bedroom's not good. If you hear those, you reiterate them to them. They understand that you understand it. And then I oftentimes found that when I go back in for payment and I go, Mrs. Jones, you talked about the air going down to your daughter's bedroom in the back. I actually found the damper was closed in that grill. Okay. And I made a change there. And you also brought this as a concern. And and so as you validate what you did and you go over with her, all of a sudden there seems less resistance to collect the payment because you now perform the service that she anticipated.
And plus, you're showing her that you addressed the concerns that she gave.
Right. So yeah, I'm done. You owe me $250.
Yeah. Yeah.
What? Like, can I mail that in? No, we don't do that. And then you get into this whole argument. But I think when you take the time at the end to go over that with them, it goes over well.
And really, it's about relationship building. You want to have a good relationship with your customers, so that they're happy to see you. That's how I built a very strong business that way, where customers kind of became friends.
Right.
And and I was honest with them, and tried to keep their equipment going. But yet, when it came time that they needed a new piece of equipment or whatever, they did. For most of the time, they never even checked me on price. I didn't take advantage of it.
Right. But they don't shop around.
Right. So that's we got off on a tangent, but kind of a business tip for you. Now, anyhow, back to maintenance and service. So what we came up with is, take off the blinders. And what we mean by that is very simple. Many times you'll get a call for service or even the maintenance, and you're on the way to the job, and you're thinking about it, and you're going through your thought process, and you're almost diagnosing the problem before you get there, especially on service. And I, every once in a while, I just kind of have to slap myself and say, don't diagnose before you get there. Let's wait, we'll get all the information, and then we'll go from there. So we're not going to be one track going in. We're going to sort of look at everything, and that's followed up by this. How do we begin? What are the components of the system? We're looking at everything. We're widening the vision. No blinders. Blinders, cut off that side vision. So what are the components? That's what I always wanted when I'm going into a new customer's home, or the first time I was on a job. I want to know, where's the indoor unit, where's the controller or thermostat, where's the outdoor unit, and I would be talking to the customer saying, I will be walking around between these pieces. Is that okay with you? And just making sure that she's aware that I'll be walking around the unit. Maybe she wants to keep the dog locked up. What does the install look like? That's when we get into Mitsubishi and especially ducted systems, we're going to go over that. How does the size compare to the load, or what is needed to cool or heat the space versus the capacity? Let's call it the real capacity of a system, and that's a little bit more advanced. But in some cases, especially with multi-zones, Mitsubishi's a whole different animal than standard air conditioning and heating, right?
Correct. Right. And so like when I look at this and I think about this particular topic is this. Okay, so you get a call, and what they're going to do is they're going to say, for instance, okay, my bedroom is too humid. My daughter's room is too cold. Mm-hmm. This room's too hot. And they're going to give you this feeling, complaint about the system. Okay. And then what we usually do is grab our tool bag and they walk us to that room.
Right.
And you're standing there looking at this wall unit. And so oftentimes you will then think about it in that time frame. You now have just burned up 30 minutes of your time in the home, in the bedroom, setting up, looking at the unit. And then what we get all the time is then we get a phone call, and we'll say, okay, so what are you working on? oh, and a GL unit in '09 hanging on this wall. Well, what is the complaint of the consumer? Well, it's this. Well, can you tell me what you have outside? No, I haven't been there yet.
Yeah, I don't know.
Right. Or is there a branch box? I think so. I'm not sure. Okay, does every line set run to the up? So what we're saying is this, is take the blinders off. When you pull in, you should know what you're dealing with totally.
As a whole.
We need to know whether it's a ported unit. You would need to know if it's ported. Is it a branch box? Is it a one-to-one? Is it a multi-zone head? What are the controllers? All of those things, because all of those things today will affect the way that the system operates. And what we say is that you burn up too much energy being, blinders on and just looking at that unit going, so I wonder why it's not cooling.
Yeah, let me put my thermometer. Let me go out to the truck and get my humidity meter. Anyhow, so put everything together. That's our system. We're there to look at the whole system. Okay, we need to be looking at the whole system. Okay. So, when I'm there, especially, and we'll get into preventive maintenance a little bit here, I like to start at the indoor unit. The reason I like to start at the indoor unit is because when I get outside, I may find out that I've got a dirty coil, or I want to wash that coil, or need to wash the coil down, and I'm hosing it down, and now I'm nothing but mud surrounding that unit, which is all over my feet. I'm sorry, booties aren't going to cut it when you go back in the house. Be taking your boots off. So I like to start inside, do my preventive maintenance of the indoor unit, and then go from there. Air filters, and I'm going to touch on this. We've got multiple types of air filters, and in the unit, mostly the large one that slides out that we're all familiar with. But I did want to, we'll get to that in a minute. But we got the different types. So indoor unit, preventive maintenance, what are we going to look at? Okay. About inspect and clean the blower wheel. That's always like the one everybody worries about. You look in there, blower wheel's got all that something on it that looks fuzzy, and when those cups in the little blower wheels are flat, they don't move air. So blower wheel may need to be cleaned. We're going to actually get into cleaning a blower wheel and the right way to do it. So inspect and clean the fan motor, no oil ports. That's like oil ports are gone from everything anymore, But that's my mindset from years ago when every motor had to be oiled. So it all just pops up in my mind. Inspect and clean the drain pan. We'll show you part of that. Inspect and clean the coil, water only. That's Mitsubishi's statement. And the reason they say, well, not the reason they say that, but they don't want anything eating into their coils. There is a small coating on Mitsubishi's coils. We cannot use harsh cleansers at all. The goal here is to prevent the oil from getting dirty, and when it does get dirty, it only needs a light cleaning that oftentimes you get away with water only. Rinse it down. Now, a little bit of cleaner if we need it. I found Simple Green works.
Right. So yes.
Very good.
So a light diluted solution of Simple Green could be used on that indoor coil. One of the things that I think also, what happens here too, and the one thing that I would really warn you to stay away from is this. You want to stay away from self-rinsing coil cleaners. Right. Okay. Oftentimes it's suggested, and as a service tech, we think like, oh, okay, I can just spray this on. It'll, condensate. It's in the air conditioning season. Just rinse that off. But what you have to understand too, and think about this, is that if I'm getting variable frequencies of flow of refrigerant in that coil, sometimes the condensation that's taking place on the coil may not be 100% of that coil.
It's true.
And we get areas of the coil that are not truly condensating with the moisture, also depending on the humidity level in the room.
Right.
Okay, so what can actually happen is that cleaning agent can then dry and adhere to the coil fins, which then will actually allow more of the dust and dirt in the
It'll grab it.
Grab it.
Yeah.
And also then that water also can affect water management. What do I mean by that? So all of a sudden you do maintenance, a few days later, the people call you back that they're getting spitting coming off the coil. And you're watching these little bits of droplets or moisture being blown off the coil. And it's like, it didn't do this 2 weeks ago before I was to clean this. Okay, did you use cleaner? Oh yeah, I did.
Yeah, and that causes.
All right, we're getting reverberation here. Somebody's got a mic. Is that possible, Doug? Yeah, we're looking here, guys. But what happens is this.
Here at the beginning of the program, if everybody could have their mics muted on that, just move your cursor on the screen and it'll show a microphone. It needs to have a circle.
Well, somebody might have done that. They may have just signed in and realized.
Yeah. And that's why
I'm glad you guys have joined us right now. Yeah. So we're going over the filters. We're going over cleaning coils. And yes, so mild detergent, but make sure you get a good rinsing of that. Because like I said, what happens is if you think about how narrow those aluminum plates are on the copper tubes, and the water is supposed to follow that plate down. If it comes down and hits a gap that's filled, then that water droplet comes out to the face of the coil. The air coming across that coil is then going to possibly blow that off.
It has to do with if you have a partially wet coil and a partially dry coil, right at where those two meet, you've got higher velocity air going across the dry section. It'll carry the water right away, and that carries to every coil basically.
Yes.
Something to be careful about. So inspect your circuit boards, wiring connections, replace the filters as needed. Now, what I wanted to show you and get into, which if you're looking at the service manual, installation manual, you may not see this, but in the homeowner's operation manual, I would recommend that you point this out to your customer. Now, right up in here where I've put an arrow, which should be on your screen, clean the air filter every 2 weeks. Is that really going to happen? Well, I'll tell you what, if you don't show that to your customer, it'll never happen. But there will be a percentage of them that will at least think about it if you say, oh yeah, this should be pulled and cleaned every 2 weeks. Now, again, the goal is stop the dirt and dust on the filter and don't let it penetrate through to get on the coil. And if they continue to do that, you will have a much easier time when it comes time to clean the coil.
Right, and the reason for the every 2 weeks, or even like so if I told somebody every 2 weeks, I'm hoping they would at least do it monthly. Like when you pay your mortgage, pull the filters out, put them in the sink, wash them, put them back in. They will air dry and they will, become effective again. Okay, the reason being is this too. Remember, guys, these units are sampling air 24/7. So there's air movement through them constantly. So, we usually think about it. A gas furnace, we tell the people change it every month.
Right.
Okay, and that has on and off cycles. A wall-mounted unit is running 24/7. So the amount of air exchanges taking place is twice that of a gas furnace or an air handler. So yes, so asking a consumer to look at these or check them every 2 weeks during operational times, which most of them are now heat pumps, is all year long, really needs to be done.
Yeah, and it's right there in their operation manual. So it's not you telling them. It's like, but I would point it out when I'm going through my checkup or when I'm turning over up to a customer, I would be showing them this. So make yourself easier. So one of the, and I'm just going to slide, and this will take a minute to get ready, Doug. But one of the big concerns that we hear about is, well, it's so hard to pull the blower wheel when it gets dirty. How do I clean it? Do I put a bag underneath it and spray it out with a hose? Or all kinds of different methods have been developed, but the easiest is the Mitsubishi method. So when we'll talk about it, and I'll show you how to find this later. Mitsubishi has a website with many videos available. They're called Tech Tips. And this is one of them. And the easiest way to clean that blower wheel is to actually pull it out, take it outside, hose it off with a hose with high pressure nozzle, not super high pressure, but clean it out, let it dry, and then reinstall it. And in this 2-minute video, we're going to actually let him show us how it's done. May not be exactly the same for every unit, but the basics are there.
And I will say this, Jim, there's 2 things I wanted to just backtrack on. First of all, if you do this, first time may take you 15 minutes or so. Some guys say that they can now get it down to about 5 minutes, 5 to 7 minutes in and out with that blower wheel. The other thing too is we mentioned about the big filters and the big ones in the front being done every other week. Those can be washed. They do have about a 10-year life expectancy of those. The smaller filters do not get washed.
Right.
If you read in the consumer guide, they are actually recommended to be vacuumed.
Right.
Because they are basically a paper product, or they're going to degrade much quicker if they get wet.
Yep.
And they are basically only good for a year.
And there's also good information there for those particular filters of exactly what do they do. I always got the question, well, what do these do? It has to do with allergies. Okay. All that information's in there. We're not going to do it. We're not going to go on it now. So, Doug, how about hit and play? And we'll take a look at how to remove a blower wheel.
Hey guys, Jeff here with Mitsubishi Heating. Welcome to another episode of Tech Tips. Today, we're going to be taking a look at how to remove a blower wheel on one of our wall-mounted units. The first step we'll need to take is to remove the front cover of the indoor unit. You'll find there are several screws on the bottom of the unit you'll need to remove in order to get the cover off. The next step we'll want to take is to remove or lower the drain pan. This will give you much better access to work with the blower wheel and its surrounding parts. The drain pan is not physically attached or secured to the unit. It's simply held in place by tabs on the bottom left, right, and in the middle. The next step you'll want to take is to loosen the set screw that holds the blower wheel onto the blower motor. You'll find this on the far right side of the blower wheel. If you spin it, you'll eventually find an opening where you can insert your screwdriver. The last step requires you to remove 3 screws on the left side of the evaporator coil. Once these screws are removed, you can simply lift the coil out towards you and then grab the blower wheel and pull it out. Now that we've got the blower wheel removed, here's a couple things to keep in mind. When cleaning the wheel, avoid using chemicals. I'd recommend sticking with good old-fashioned water. I use a water hose and a nozzle. The second would be, try not to lose the bearing that's located on the left side of the blower wheel. And the third is to locate the set screw that holds the blower wheel onto the blower motor. The set screw has no dedicated spot, or commonly referred to as a flat spot, on the blower motor. This helps when putting it back together. You don't have to worry about where it's aligned. And lastly, to reassemble it, just reverse the steps we took to remove it. For additional information, please feel free to visit our website at www.mylinkdrive.com. If there's any videos you would like to request in the future, please feel free to leave a comment below. Thanks for watching. Make sure to subscribe to our channel for future episodes of tech tips and homeowner help.
Right, he definitely makes it look easy, doesn't he?
And it may, quite honestly, it may not be as easy as that. I mean, I've got a tip there too, is don't remove the screw from the motor shaft, all the way, because if you do, you'll definitely need a magnetic tip Phillips head screwdriver to get it back in.
Right, and another tip that I know that actually a guy in the field that worked on this all the time taught me too, is that if you actually look at that drain pan in that picture that's still there, you can come up over on this edge over here on the one edge, and he actually uses just a small nylon tie strap to take the weight of the drain pan that's hanging off of the cables.
That's a good idea.
With the electrical strain that could be in there and the polarized plugs. So he basically, before he did that, went through the little hole that goes over the offset. So when that drain pan snaps on, there's a little knockout there. He puts the wire through the knockout, grabs another part of the unit and lets that hang. And then it's kind of not in your way either.
Sure.
So there are little tips that guys will pick up over, a process of time of doing this, but it is really quite simple. And if the big key is lifting that coil up a little bit, then when you slide it back in, drop the coil back down, re-secure the bearing on the one end of the, wheel, and way to go.
Yeah, it's good to go. Now, the other thing is, when that drain pan's hanging loose like that, it's very easy to take a cloth or towel, paper towels, and just wipe it out.
Yeah, bleach wipe, something like that.
Perfectly clean drain pan now. Okay, so along with a little bit on service things, and you're going to find out as I go along, especially I've developed the terminology of when we get into service, voltages and observations. Well, here's an observational side of things. Now, again, on the screen, it's not always as easy to see this, but on your computers or whatever device you're looking at, you should be able to pick up some details. But on this unit here, you can see on this left slide, and thanks for putting up with us drinking your coffee because it's early yet. But you can see our unit's right up against the wall, and this is a close-up of it. So I believe that was no, it's not this.
No, I can tell
job.
you. Well, this job was mine.
Yeah.
Okay, I went on a field visit in Gettysburg, PA.
Okay.
Drove out to Gettysburg to look at this particular unit. This unit was actually in the consumer's kitchen.
Oh, okay.
Okay, and her complaint was it is not reaching set point. Okay, it is not doing its job properly. So one of the things that we found out was then when I walked into the house, we stood in the living room entryway, went over everything. She walked us back to there, and I looked at the installation. And I can tell you, as you can see, the right-hand side of that was up against a chimney,
An
offset box in the kitchen. The other left-hand side was right against the door jamb.
Oh my word!
So if you would look, there was, I would say, probably about 3/4 of an inch of space on the right-hand side of that unit to the chimney. Okay, and what we found out was that we were not picking up enough return air through the unit to be able to truly get a good sensing and a good operation.
And we'll explain why very shortly.
So that was the main thing, is that if we realized that, our return air sensor is on that side and we blocked the airflow that should have went over that.
Exactly.
And so, here we went out, dealer's been out 2-3 times. Oh, can we have the DSGs come out? Let's look at this. And immediately we looked and said, this is an installation issue, application issue. And the result was the dealer wound up having to disable that particular sensor, install a remote MHK controller in the room, and sense temperature from that rather than using the one that was built into the piece of. So realistically, it cost him that service call, a returning service call, plus giving her another free controller.
Sure.
Because, and the whole point was it's not keeping up. It's not doing what it's supposed to.
Okay. Yeah. And along similar lines, on the right-hand picture, we can see the bottom of the unit where the corner piece was taken out. And when that was removed, we could see, I think this was another one of your pictures. And quite frankly, a lot of these pictures are what John has taken on some of our field visits that we've been out there. So there was another one where take the corner piece off and you see light through. Well, what does that mean? Why does that matter? Well, we'll get there. But first of all, Mitsubishi's instructions tell you when you put a wall unit in, it must have a sleeve going through the wall, it must be pitched downward, it must be insulated, and it must be sealed on both ends. We cover that in the 2-grade class 4 depth as to why we need to do all that, but we're going to hit this one.
So on that particular, it's always, you do not, so that the standard would be, you do not want to see daylight.
There's no way.
When you remove that corner piece. Or if you were outside and you took the top of your line height off, you do not want to be able to see the back of the unit.
Right. The other thing's tough to see, but in the right-hand picture, there's some wire nuts in there that don't need to be there. I believe they were on the S1, 2, and 3.
Yes.
And as you should have learned, anything with Mitsubishi, there are no breaks in that wire between the indoor unit and the outdoor unit. No connections. Temperature sensing. Well, what about temperature sensing? John alluded to that earlier, where they were having issues with temperature control. The same thing would have happened on the right one. So if we take that unit and look at the right-hand end of it, there are would be vents. Well, why would vents be there? Well, that's because in the scheme of things, in the airflow pattern inside these wall units, this is a low pressure area. And if you take notice, it's also directly in front of where the line set and wiring would go out the right-hand side if you chose to use the right-hand outlet. So therefore, that's a low pressure area in the airflow, and it's picking up temperature air through these little slots, these little vents, and the indoor air sensor is right on the other side of that plastic. So as the air comes through, it knows what the room temperature is. It compensates for the height versus down where your customers are, but that's how you control the room temperature. So if you can't get air there, you're not going to have proper control. And especially if you're open to the outside air at that spot, you're bringing that outside air, whether it be cold or warm, across the sensor. In the wintertime, it's going to feel that cold air and it may overheat the space. Summertime, the opposite.
Overcool, because you think about it, when you look at the size of that hole in the wall,
Yeah,
3-inch round hole, with your stuff coming through, or a small few slots under that negative pressure and that the vortex of air that's being circulated in there constantly.
Right.
It's going to pull from the least resistance,
Right.
which is going to be the bigger hole, and then we're not sensing, you know, that temperature. And you did bring up something, Jim, and I'll just say this real quickly here. With this, is this, that sensor does have an offset built into it.
Right.
So when a consumer takes a remote and points it at that head and says, I want it to be 70 degrees, in reality, that indoor head is actually working at about, let's just say 73 point something degrees, because it's actually a Celsius conversion.
Sure, it's a metric, yeah.
Right. But it's figuring that extra heat up there, and it's going to cool down. So this is another reason. So like, okay, another possible service call would be like, okay, it's overcooling the room. You walk into some of these rooms that have family rooms behind the house, cathedral ceilings, and the head is now 12, 15 feet up.
Right.
Think of all the heat that's rising up to that point, and we're now working off of that, and we're now overshooting down here. And it's not a refrigerant issue. It's not an electrical issue. It's a placement issue.
It's not an equipment issue.
Right. And now all of a sudden it's going to be like, okay, we're not going to be able, we're going to have to disable that sensor. We're now going to have to put an MHK one in here where we're sensing more in the room space, not because the offset, there's nothing we can do about that offset on that piece of equipment. At this point, I know that there's an additional slide, Jim. I don't know if you want to get to that. Do we want to open up for, is there any chat going on, Doug? Or is there any questions? Any questions that you guys want to unmute on? Because very shortly, we'll probably take a short break and give you guys about 10 minutes or so to be able to use your restroom at home or at work, you know, get a coffee, do something like that. So that will be coming momentarily.
Yeah, so let's continue for a few minutes anyhow. And when we get, you know, we're going to go next to your checkout for during a preventive maintenance or a service call. There are some rules of thumb. Please don't get caught up with these, okay? But there are some rules of thumb with Mitsubishi, and the biggest ones are in the cooling mode that, and we're going to say it right away, in test mode that you will have generally 20 to 30 degrees drop in cooling across your indoor coil.
And maybe Jim, you ought to define what we mean by test mode for the new guys.
Yeah.
Oh, you're going to get into that.
We're going to get that on the next slide. We don't just walk in, check our temperatures, and that's it. You know, we're there, and we've alluded to refrigerant being critical. We never put gauges on as the first thing we do when we walk up to a piece of Mitsubishi equipment. The other thing we never do is cycle power. Okay, we always do our observations first. When we get to the heating mode, you will generally see 30, 35-degree rise through the wall units in heat mode. The other part about the cooling is that the outdoor unit, if you were to have your gauges connected, you would see anywhere from 0 to 5 degrees of superheat. That does not mean that if you're suspecting a refrigerant problem and you do end up putting your gauges on, that you just add refrigerant until it's 5 degrees of superheat. It doesn't work that way. That we get into in the more advanced classes as to why. Any comment on that other than a rule of thumb is a rule of thumb? These are generalities. Now, how do we get to what I call test mode? Well, on our wall units, we have what we call an emergency operation switch. And that emergency operation switch, if you push it one time, it will go into cooling mode and it will run at test. It will run at test for 30 minutes. What that does is it's not 100% run. It sets, and we can find this in the service manuals. By the way, there's a service manual for every piece of equipment. We'll go there. But it will put it into test mode at a certain frequency for 30 minutes. Now, the nice part about it is it says emergency operation switch. Well, let's say the dog chewed on the remote control. It happens. Well, you don't have one of those in your back pocket or on your truck or probably shop. If you let that in test mode, in emergency operation mode, after 30 minutes of test run, it will revert to 75-degree set point, and that will be for both heating and cooling. So you push the EO switch one time, it goes into cooling mode. You push it 2 times, it's in heat mode, and you hit the 3rd time, it will come out of test mode.
Right, and it will, and if you leave it in that mode, you do the first half hour of testing, and then it indefinitely will hold that. So if you forget it and pull out the driveway and you're at the end of the development, okay, you just left them soon going to be at 75 degrees for the rest of the time period until somebody realizes it makes a change.
Until you go back to fix it.
Yes.
And cost your company money. Okay, so I think enough of that. So when you're going to do, that's as part of your preventive maintenance, we don't hook gauges up at all. We shouldn't need to. Just like your refrigerator, should never be losing refrigerant. But we can put it in test mode, check our splits. If the splits are good, we know we don't have a refrigerant issue. So that's enough about for the indoor unit to start with. Outdoor unit, let's get back into preventive maintenance mode a little bit. We're going to look at that unit and we're going to look for dirt, debris inside the cabinet. Being a horizontal discharge, it's not like your air conditioner or heat pump sitting outside that the leaves can fall in from the top, but eventually things can blow in. Leaves are blowing around, they're getting broke up, dried, those little helicopter, you guys have all been there, but things can blow in, some blows out when it comes on, but eventually it can build up. We're going to look at our drains for obstructions, so that the units can drain properly. I got ahead of myself. We're going to look at that coil. Again, cleaning the coil recommendation is water only. That being said, if you need a mild cleanser, we're not going to fault you. We need clean coils. But anytime you use a cleaner, and if you have used, for example, one of those self-rinsing coils on the indoor unit, just get it rinsed off very, very thoroughly. Inspect the fan motor blades for wear damage. We'll get into that. We're going to look at our circuit boards. We're going to look at wiring, loose wiring, colored wiring, which may show that it's loose and heated up for our connections. Let's look at our piping. The refrigerant piping that's going on around the unit. Has the insulation fallen off? We'll go there too.
And looking at inspection on the piping, Jim, we've seen this already. You will notice that this particular picture is actually on a home in Philadelphia.
Okay. Pictures.
Right. And not only was our Mitsubishi on the roof, but other apartments that were in this commercial building that was converted over to lofts. Okay. There was other units there. Okay. Well, guys are climbing over each other's units to get to this thing. And you will find line sets that have been stepped on, line sets that go over a curb, now have a bend in it, a kink.
Right.
And so you're looking at all, so it's not just that. And the other thing that you're looking for, and really when we talk about insulation on the pipes, and maybe somewhere else we'll talk about this, but just really make sure that it's all the way up to the nut, of the unit, and that we have it there. Exposed piping is going to be BTU loss.
It is. And in the engineering world, an inch of piping, they're able to measure the BTU loss. It may not mean a whole lot, but if you get a lot of gaps of 2-3 inches all along, that may have.
And when you think about it, Jim, you and I have been in the industry long enough before there was UV rated insulation. So I can tell you that I know that there's a lot of black Armaflex that is probably missing on a lot of exposed jobs, roof jobs. And you think about it, on this particular job, you could have 15, 20 feet of exposed line laying across that black hot roof before it goes down to a pitch pocket.
Right.
And that's kind of the way this was. And so you want to make sure that that line does have its insulation, that it's intact, and that, we're fully insulated.
Yeah, and as a tip, I used to carry at least one length of split insulation with the sealing gum on it, of one of each size that I would carry just to have it. And when I on a preventive maintenance, if it was bad or was very deteriorated, falling apart, you walk up on some of these and it's hanging off the pipes.
So yeah, and I'll just I'm going to go a little bit deeper here.
Let's go off at a tangent.
No, it's not really a tangent, Jim, but it's a further explanation of this situation. Because what happens is this, okay, one of the things that Jim and I have seen, Doug and I have seen as we go out is this. You start getting 4, 5, 6 inches of insulation missing. And this happened in Philadelphia, outside in the Torresdale area. Went out, looked at the line, and there was the line. What we realized is when we put the maintenance tool on it, which is another class that we offer, okay, and using that maintenance tool, we were able to see that refrigerant leaving the unit was, let's say, 45 degrees.
Okay.
By the time it got to the indoor head, it was 10 degrees warmer.
How about that, right?
Okay. What we found out was that the lines that had come out horizontally, drooped down, ran around the house, and then went up the pipe. Well, that whole long 10 feet was filled with water from where the pipe had been condensating.
Inside the insulation.
Inside the insulation. We wound up pinching a finger, how, okay, I'm feeling for kinks.
Okay.
And you all have been there. You feel through the Rubatex, and it's like, is that a kink or not? So you take your thumbnail and you kind of, as soon as I pinched that, I got sprayed on with water.
How about that?
The water rolled out of that Armaflex onto the ground. And I would say that it at least was a 16-ounce cup of coffee.
Okay.
All of a sudden, when the water drained out between the insulation and the piping, which was wicking off the BTUs,
Right.
okay, we watched 45 degrees leaving, 47 degrees. Yeah, we came up 7 degrees
How about that?
in our temperature just by getting that water off.
Right.
So that's what I'm just saying. Insulation and visual inspection of insulation is really critical.
Right.
And those are some of the things. So like all of a sudden somebody's complaining like, the hottest day, that head just does not keep up. Who thinks to go up on the roof and look at the insulation that isn't on the pipe anymore?
Right.
And now you got a beating sun down on it, and you're wondering, where did your coolness go?
Right. Yeah, and a lot of that has to do with the way that Mitsubishi units work, especially ported units or one-to-one, where your metering device is outside, without getting into too technical, but you're trying to change state of refrigerant from your metering device in the outdoor unit to the head. And if it has heat in between, you're going to change state before it gets to the head, and there won't be enough to cool the space. So I see we are about time. It's a good time to break. So let's say 10 minutes. And so about 9:10, please be back. And we'll see you in a little bit. Thanks, guys and gals.